Today we are going to show MCAD collaboration between Xpedition and NX. In this example, we will follow a typical design flow. MCAD defines board shape and critical connectors, which will then be passed to ECAD. You can see the design has been placed and outline created. You can also see the component information in the PC Design Navigator. This separates the information item by object type, where you can see components, cell names, ref des, and part number, as well as outlines and mounting holes. Finally, we will export this information via a baseline to Xpedition. This is unlike any other collaboration file, as this retains a unique identifier for each design object. You can validate the data in the information dialog on what has been exported. Open MCAD Collaborator. This is an interface that allows you to visualize information before it is applied to your design. In the Files section, you can see the baseline.idx file automatically populate to show that there's collaboration files that actively need to be addressed. Here you can highlight information like the board outline to preview data, and even see information on component data like cell name, the X and Y location, and other important information for collaboration. Once the data is applied, you will see the newly updated design. The synchronization state will show that you are ready for importing proposals. Baselines and proposals can be sent at any time. History is automatically updated to allow designers who come back to the design after a period to understand the true design intent during the entire design process. Notice that during the import, we see that one of the components is using the 2.5D extrude. This is due to the fact that the component is not currently modeled. We will use the VX 2.3 features to allow you to quickly align and seat the 3D model to your 2D cell. First, we will import a third-party model. Notice, as you import, you can now see the green arrows that indicate direction for rotation. We can simply select these icons to rotate the part in the right location. Next, we can define a seating plane where the 3D model sits by selecting the bottommost surface of the 3D model. You can also see that the pins are misaligned. We can center the pins of the 3D model using the pin pad command to the through-hole pins in the cell. We now have our model fully aligned. We will skip ahead in the design process to mimic the placement of the entire design to speed up the collaboration process. The functionality for the 3D environment is not limited to just the 3D view. You can take advantage of the 3D environment while still pushing in the 2D view. We can tile the 2D and 3D views side by side and control how the view is driven by 2D or by 3D. This will allow you to identify 3D design violations while still working in the 2D environment. Display control has a plethora of functionality that allows you to turn on and off the visibility of items in a 3D environment. In this case, we can see the component pads as well as the pin through via holes in the design. Let's exchange our newly placed component location data with the mechanical design team. Notice, as changes are made, the Get PCB data button is highlighted yellow to show that there are differences in the data versus the imported baseline. Also, you will be automatically placed in a proposal stage where only the items that have been added, modified, or deleted will be shown. At any point, you can switch to a baseline file and send the entire information again. You will see that we only have component information with the XY location and other important information, as well as the primary pin location. We will send this as proposal 00.idx. We can then import the proposal and visualize the data prior to applying the collaboration data. In this example, we will just want to accept all component data. This will automatically create a response file, which is required to close the loop and synchronize the two domains. The response file is automatically highlighted, and we can see all items have been accepted. We will test the exception rejection process, where we will modify the location of a USB connector and board-to-board connector. In Xpedition, you can highlight the movement as well as see the modified location prior to sending the data. We can also write a comment to capture the true design intent. In the mechanical domain, we can review the two component changes and see that the USB connector has been moved. As a mechanical designer has made several key constraints on this particular connector, this component should not be moved, and we will reject the change. The other board-to-board connector is connected through a cable, therefore it can be modified to alleviate routing issues in the electrical design. The electrical designer can review the response by the mechanical designer and see that they rejected the USB connector movement, but they accepted the board-to-board connector. Once this is applied, we are now synchronized and can continue sending incremented data from either domain at any time throughout the entire design process.